Hello everyone, welcome to my YouTube channel. In this section we'll talk about further inequalities. In my last session we talked about quadratic inequalities, but when we face more than one inequality at the same time and we have to prove both of them to be correct, how do we cater to that? Let's start. Okay, so we have a question like this. So first step, you solve both of them relatively. So x squared minus 4x minus 12 is less than equals to 0, and I straight away use my calculator for solving it, but you can use many other methods. So x turns out to be -2 and x is equals to 6. For the next one, 4x, it's a linear inequality, equals to 1 plus 3, and x is greater than 4 over 4 and x is greater than 1. So sketching quadratic now, this is 6 and -2. So less than or equals to 0 means this region. And I can say that according to this quadratic inequality is -2 less than equals to x is less than equals to 6. But the linear inequality demands that x has to be greater than 1. So if I say x is greater than 1, there's going to be x is 1.1, 2, 3, 4, more than 1. But it says x is greater than -2, which caters to -1, 0. So if I take -1, 0, then these two values does not comply with this one. So both the inequality has to be true. So that is why we take 1 is less than x is less than or equals to 6. In this scenario, both of them are true. As you could see, x is greater than 1, which caters to this part of the inequality. X is also greater than -2, which means greater than 1 also is bigger than -2. And this inequality, and x is less than or equals to 6, because x is just greater than 1 in this inequality, but the other inequality stops it at 6. So both the inequalities are true in this scenario. Let's look at another question here. So x squared plus x minus 2 greater than 0, and x squared minus 2x minus 3 is greater than or equals to 0. So now so x is equals to 1 and x is equals to -2. Now taking the other inequality into account, x equals to 3 and x equals to -1. So sketching both of them, so if I sketch this, this will be a smiley face with the roots at -2 and 1, and this with the roots -1 and 3. So if I highlight this, it's greater than this and greater than equals to this. So this is going to be x is less than -2, where the curve is positive, greater than 0, x is greater than 1. For this one, x is less than or equals to -1, x is greater than or equals to 3. Now both the inequalities have to be true. So x is less than -2 could be -3, -4, but it says that x is less than or equals to -1. Now if I say x is less than negative or equals to -1, which means -1, -2, -3, and so on. But if I write this, if I take this into account, this means -3, -4, and so on. So can I say that this region is common? And this is what I need to cater to. So if I take x is less than -2 only, this will be true for this one as well, for this inequality as well as this inequality. Both of them are going to be true, not completely, but both of them are going to be making a settlement for x is less than -2. And for the other one, x is greater than 1 and x is greater than equals to 3. So x is greater than equals to 3. If I take this into account, then this inequality will automatically be true as well because x is greater than 1. So x is greater than 1 means 2, 3, 4, and so on. And x is greater than equals to 3 means 3, 4, 5, and so on. So if I take x is greater than equals to 3, this will be true for both the cases. So the final answer is going to be this, where both the inequalities are true. So let's look at another question here. So solving both the inequalities. So x is going to be 5 and x is going to be -2. For this one, x is 7 and x is going to be 3. Now, sketching both of them. So if I sketch, so one root is at -2 and the other one is at 5, and the curve is below 0, which is below the x-axis. So the inequality is going to be -2 is less than x is less than 5. For this one, sketching that as well, so it's going to be 3 and 7. And since this is as well below the x-axis, less than 0, so we say that is going to be 3 is less than x is less than 7. So let's look one half of it. This says x is greater than 3 and this says x is greater than -2. So I'll take this value because 3x is greater than 3 will automatically be x greater than -2. So 3 here less than x. Then look at the other half of it. This half. X is less than 7 and x is less than 5. So if I take x is less than 7, so 6 is going to be there as well. But if I take x is less than 5, then 6 is automatically cancelled. So both of them will meet at x less than 5. The reason being that in this scenario, this as well will be true. So that is the answer. Now, you may try to pause the video and try to solve this question on your own, and then you can check for your answers. Until then, I'll solve this myself. So 2x squared minus x minus 1 is less than 0, and 7 minus 2x is less than 6. So both of the inequalities. So I'll solve this using my calculator. So x is equals to 1 and x is equals to minus 1 over 2. So the region is less than 0. So I'll write this inequality. Negative half is less than x is less than 1. Now solving this, it's just a linear. You don't have to draw it. So 7 minus 6 is less than, I'll take 2x over there, and 1 over 2 is less than x. You can also write this as x is greater than 1 over 2. Now, let's look at this part. This is just one-sided inequality. X is greater than half then x is greater than negative half. So if you say x is greater than negative half, it will cater to some negative values as well. But if you only look at this one, it says that x is greater than half. So which this inequality will not be true in this scenario. But if I take this inequality, then this as well is going to be true. The reason being that x is greater than negative half means that x is greater than half as well. So I'll write 1 over 2 is less than x is less than 1. This is going to be my final answer. So when there are multiple inequalities, you need to find out a middle ground where both the inequalities justify each other. For example, if I say x is greater than negative 1, and if I say x is greater than 1, so this is not going to be possible. The reason being that x is greater than negative 1 caters to 0, 1, 2, 3, 4, and so on. But if I say x is greater than 1, it caters to 2, 3, 4. You could see that some of the values of x is greater than negative 1 are overlapping x is greater than 1 as well. So those values you can accept in both of the cases. So that's why if you take x is greater than 1 as your final answer, this means that x is also greater than negative 1. So this is how I try to convey the inequalities where two of or more than two equations or inequalities play its role. I'll come up with my modulus lecture related to quadratics in my next session. Until then, take care. Bye bye.